Good morning. We're going to finish up today. We looked at the conversions already for cylindrical and spherical. You can find them. Now we're going to work with them. Given a cylindrical point, ask to write it as a rectangular point. What is R? So in the order triple for cylindrical, what is R? What's theta? No, this would be the easy one. What is cosine of pi over 3? Sine of pi over 3 is what? And what's the z coordinate? That would be your point rectangular. Rectangular point in the cylindrical. So remember r squared, x squared plus y squared. Two squared and two squared. So what is r? Simplify it. 2 squared root of 2. Bless you. So look at the projection of your point. What quadrant is that projection in? What does the inverse tangent give? So what would the inverse tangent of -1 be? Oh no, we don't remember our inverse trig functions. That's not good. That's very sad. That'd be the inverse tangent of 1. Be -π/4. What quadrant is that? -π/4, what quadrant? It's the 4th quadrant. If you look at the coordinate system, negative says you're going clockwise from the positive x. So it'd be that angle right there. Which means the point would be that, which is not our point, is it? Because our point's there. That's the angle we want. How do you get it?
Subtract fourth from
Yes, which has the same effect of, I'm sorry, you said subtract π/4 from pi? Yes. In terms of using the inverse tangent, add pi. Remember, you can't just blindly use the inverse tangent. So what is our angle?
five.
I think you did the wrong sign on inverse tangent. Three π/4. And z is just 3. There's your cylindrical point. Spherical to rectangular. How do you find the x-coordinate?
It's rho cosine theta sine.
What is rho? What's theta? And what is phi? What's cosine of pi over 4? What was it? Sine of pi over 6. It's a half. Isn't that just 2 root 2? What's y? How do you find y?
It's rho sine theta cosine sine theta sine.
What's sine of pi over 4? Y is the same as x. 2 root 2. How do you find z?
Rho cosine.
What is cosine of pi over 6? That would be our rectangular point. Rectangular to spherical. What's the relation for rho? Hmm? Do you need a what?
Sorry. Do I need like a sheet?
Oh, you're trying to sign in?
No, I already signed it.
Okay. Sheet for what?
The quiz.
Oh, we're not doing the quiz.
Oh.
Quizzes will be online. I'll discuss it at the end. Okay, I'm already very easily confused. Don't confuse me anymore. So what is the conversion, or the relation, the conversion relation for rho?
Square root of x squared plus y squared plus z squared.
So technically not,
Because it's
because in theory we can take rho to be negative.
square plus or minus square root of x squared plus y squared plus z squared.
So the relation just keeps everything squared. For our purposes, yes. We're going to keep rho's positive. But I'll just stick with this. So we're going to have 2 root 3 squared. What is 2 root 3 squared? 12. 6 squared. Add that to 12. What is negative 4 squared? 48 and 16. So what's rho? Yep, rho is 8. Tangent theta is the same thing, y over x. So we get tangent of theta is root 3. What quadrant is the projection of our point located in? First quadrant. Can I just take the inverse tangent?
Yeah.
What is the inverse tangent of root 3?
Does it simplify?
It actually does.
Is it positive?
You don't sound confident in that.
It is positive.
Pi over 3. Root 3 over 2 over 1/2. How do you find phi?
Z over cosine of can do the inverse cosine, but the inverse cosine of phi is equal to cosine phi is equal to z over the square root of x squared plus y squared plus z squared.
All right, so this is the actual relation. You can just take inverse cosine. And for our purposes, this can be simplified even further. What's the square root of x squared plus y squared plus z squared?
Rho.
It's just rho. So you could write it as phi is the inverse cosine of z over rho. Cosine of phi is negative 1/2. Phi is the inverse cosine of negative 1/2. What's the inverse cosine of negative 1/2? You make me sad. Using a calculator. I repeat, you make me sad. It's 2 pi over 3. You have about a month to get really good with trig.
I used to be good at that.
You're going to need to be good at trig again.
Count 2 and 1, 2.
But we generally don't deal with just a single point, do we? We generally deal with a set of points. So write the relation x squared minus y squared equals 25 as a cylindrical relation. So we're going to represent the set of these points in cylindrical coordinates. Now, generally speaking, I think it's that. We would write r as a function of theta and z. I think another very common one is z as a function of r and theta. Well, x isn't that r cosine theta? Y would be r sine theta, right? Oh, cool. We have an r squared common. Can that be simplified?
R squared equals 25. Negative R squared.
So you were thinking cosine squared plus sine squared. For negative r squared, that would have to be negative cosine squared minus sine squared.
negative, and make it sine minus cosine.
Well, if you factor out negative, would be sine squared minus cosine squared, right? How does that simplify?
1.
Sine squared plus cosine squared is 1.
But that's the right thing to do.
This can simplify. Hmm? I can. I'm going to do that later.
What's that to that?
Well, not x.
Or 2 theta.
That's the double angle identity for cosine. I could leave it like that. Let's try and solve for r. Now, if we take the square root of both sides, square root of r squared is going to be what? Why is it just r?
Square root's only output the positive root.
Right, so when you take a square root, if you square a number, it's only positive. But if I ask you what the square root of -2 squared is, what's the square root of -2 squared?
Square root.
-2 squared is 4, but what's the square root of that?
Wait, square root of -2 quantity squared.
The -2 is being squared, and then you're taking square root.
Or 2. 2r.
It's 2, right?
Yeah.
But it was -2 being squared under the square root. So the square root of r squared is not necessarily r.
Wait, I don't think.
If you take the square root of an unknown squared, in this case x, up top, it is not necessarily x. I just gave you a counterexample.
Oh, yeah. It's the absolute value.
It's the absolute value of x. So that's why I'm asking, the square root of r squared here is r. Why?
R is positive.
We're taking r to be positive. It's measuring a distance. This is what we would get. Is that going to be allowed? Why? What are you not allowed to take the square root of in the real plane? Negative numbers. Will secant 2 theta ever be negative? Why? What's that why? If theta is pi over 2, 2 times pi over 2 is... Oh, that's not going to work because... Yeah, it will be pi. Secant of pi is negative 1.
Well, it depends what the range for theta is. It 0 and pi?
Theta goes 0 to pi, 2 over pi. Theta goes from 0 to 2 pi. In most contexts. Theoretically, minus infinity to positive infinity. Secant of 2 theta won't ever be negative, but the question is why?
Is it because R can never be negative?
Well, that's true, but that's what's that got to do with secant?
Yeah, I guess if they're equivalent. If it's the absolute value.
Well, I'm asking, why are we allowed to do this step? So you can't use this step in the justification. You looked too far ahead. What does r squared equal? R squared has to be what? Positive, right? 25, is that a positive number? That means secant's gonna have to be positive, otherwise you'll get a negative number. Right? Positive times negative is negative. And then you can't have r squared being negative. So because r squared equals 25 secant of theta, that now mandates secant of 2 theta being positive. So you can take its square root. If that was negative 25 secant of 2 theta, secant of 2 theta would have to be negative. Right? You wouldn't be able to take the square root at that point. Well, you could, you'd have to write it as the square root of negative 25 secant of 2 theta. You have to keep everything together. So that would be our final simplified form. So we're going to write this rectangulation as a spherical relation. And again, typically we want to write it as rho is f of theta phi. If only that was a plus z squared, this would be so nice. But it's not. In spherical, that would be x, right? That would be y. And that is z. Can factor out a rho squared. That can be simplified.
Can you take the sine squared,
Of what?
of the addition, and have it sine squared theta times sine squared theta equals sine squared theta.
Which is what? Which is what?
Um,
That can still be simplified.
Cosine of 2 phi.
Negative cosine of 2 phi. Does this make sense? Negative rho squared cosine 2 phi is positive 1. You know rho squared is always positive. Can cosine of 2 phi ever be negative? It would have to be in order to get positive 1. So can it? Because if it can't, then this is an empty relation. What values does phi take on? So what values would 2 phi take on? Is cosine negative anywhere from 0 to 2 pi? Yes. Perfect. So we're good. Rho squared is negative secant of 2 phi, which means that secant of 2 phi is negative. Rho would then be square root of negative secant 2 phi. I'm not taking the square root of a negative number here, am I?
No, because
We've already said secant has to be negative. You. Yeah, it's this one. That would have been so nice if they all would have been squared. But that would be too easy. We can factor out that row. Can that be simplified?
I mean, you can still take out this side.
Does that benefit us in any way? Of course.
Can you subtract that cosine? I don't want my edges.
Remember, it's being multiplied by a row, so you can't just subtract a cosine phi. Technically, there's an identity we could use, but it does not benefit us. And you could use product to sum identities on the first two terms. Unfortunately, you're not going to get anything to cancel out. You're not going to get anything simpler. So, no. That's as simple as it's going to get. So at this point, it's a matter of how do I want to write it? I think I'm going to do this. And call it a day. And, okay, going the other way now. We're given a cylindrical relation, and we're asked to write as a rectangular relation. And at the same time, let's see if we can identify what kind of shape this is. Hmm?
Like when you drop a stone into a pond.
I guess we'll find out. See if we can identify the curve. What is R? Do I actually want to do that right now? Yeah, that is what I'm going to do. R is the square root of x squared plus y squared, isn't it? What's sine of theta in terms of x and y?
Isn't it just a white color?
Technically, yes, but that's only for a special type of circle. It's only if it's unit. Can't assume this is a unit. So look back at the cylindrical conversions. Look for one that involves sine. Which conversion has sine in it? What is it? Or the other way around? Doesn't matter. Just the ones for rectangular and cylindrical. So you have 6 total relations. Which one involves sine? Solve for sine. So what is sine of theta? What was it? Not in here. In the relation you just gave me, solve for sine.
What?
But what's r in terms of x and y?
Root x squared plus.
So there's sine of theta. X squared plus y squared is then 2y. We're going to keep going to see if we can identify the curve. Subtract 2y from both sides. What do you think we're going to be doing now? I'm going to make you really think on this one. Go all the way back to algebra 1. What is it? It has to do with quadratics. So we're not using the quadratic formula.
Completing the square.
Completing the square. Specifically, we're going to complete the square on y, which will then allow us to factor.
Never goes away.
Algebra never goes away. Calculus is easy. Algebra is hard. Well, that's not plus, sorry, that's minus 2y. What do we want to add?
One.
But am I allowed to add 1?
You have to subtract.
Not. The only thing I'm allowed to add is 0. So I'm also subtracting 1. But I'm just going to do it this way. Because I have an equation. If I add 1 to one side, I'll just add it to the other. Same as adding 0. Which allows us to factor that y squared minus 2y plus 1. How does that factor? It was the whole reason for completing the square.
Would be y minus 1 squared.
It was the whole reason to complete the square, to write it as a perfect square binomial. What curve is that? Do you know? Be more specific. Because it is a circle, but what kind of circle? I need a radius and I need a center.
The center of
Center has to be an ordered pair.
-1. No, 1 negative.
0.
0, 1. And it's a radius 1. It's a unit circle centered at 0, 1. Means you now know what kind of shape that gives you. None of you are in my Calc 2, but I think I actually used that in Calc 2 towards the end. When we deal with polar coordinates and areas, I think I use r equals 2 sine of theta. A spherical relation in terms of rectangular. So we're going to have to do a little bit of manipulation here. So look at your 6 relations in spherical and rectangular. Of those 6, which one involves rho and sine of theta?
The relationship to y,
Which is what?
y equals rho sine theta of sine phi.
But we have a problem. We don't have a sine theta. Oh, that's okay. Because I can just put it in there. I just multiply by sine phi over sine phi, right? That's multiplying by 1. I'm allowed to do that. Or just multiply both sides by sine phi. That makes the left-hand side now just y. But now the problem arises. What is sine of phi? We know what cosine of phi is, don't we? What's cosine of phi? Not just z.
Zero rho.
I'm going to leave it as rho instead of writing it as square root of x squared plus y squared plus z squared. That is for my sanity. We can use this to determine what sine of phi is. Before I even move into the right triangle trigonometry, what was the domain for phi? What were the values for phi? What was it?
0.
Over 0 to pi is sine strictly positive, strictly negative, or both positive and negative? Strictly positive. I can safely use right triangle trigonometry. There's going to be phi. Cosine of phi is z over rho. But what is cosine in terms of right triangle trigonometry?
Adjacent over
What's the missing side? What was it?
B squared. B squared minus C squared.
What minus z squared?
The P thing. It's called.
I love it because every semester I get at least one student who calls it P. And you make the Greeks very sad. It's rho.
Yeah.
I think the Greeks still use that alphabet too. It's not just ancient Greek alphabet. Make the Greeks very sad. Speaking of Greeks, I could go for some Greek food right now. In terms of right triangle trigonometry, what is sine?
Opposite over.
What is rho squared going to be, though, in terms of x, y, and z? What is rho in rectangular coordinates?
Square root of x squared plus y squared.
So what's rho squared?
X squared plus y squared.
So that rho squared there is actually x squared plus y squared plus z squared. Minus z squared. You get just x squared plus y squared. Right, one of the relations in spherical where rho squared is x squared plus y squared plus z squared. That's what I'm using. I didn't write it that way for my sanity. I don't have to keep writing it. I just left it as rho. But that's what it actually is. And then over rho, which is this. That would be our relation. Or you could leave it as y and write that entire thing under one square root. That's also fine.
How'd you get from the first part to the y equals?
So this is y. Right, that's one of the relations. Y equals rho sine theta sine phi. All the work up here is how I found what sine of phi was.
Oh,
Right, it's this square root, rho squared minus z squared over rho, and I just simplified it in terms of x, y, and z. Actually, this one would probably be better because this specifies that y has to be positive. Right, because you're getting square roots, which is always positive. Whereas this doesn't necessarily specify that y has to be positive. So this one might be the best option. But it doesn't matter.
Won't still be positive if it's squared.
If I'm squaring it, y could be positive or negative. Because when you square a negative, it's still positive.
Yes.
Whereas over here, notice it's saying y is just a positive square root, which says y has to be positive. Right, so that explicitly tells you y has to be positive. The other one doesn't. Right, that's saying y could be positive or negative. So it's just a matter of taste. I don't like writing that square root. I think square root just makes everything look hideous. So I prefer everything being squared, but that's just me. What I could do here is y greater than 0. Can't equal 0 because you'll never get 0 out of x squared plus y squared. Oh, actually could if they're both 0, right? Can they both be 0 though? You know, I'm going to be safe and just say greater than or equal to. I'm not sure if the origin's actually included in that. I don't think it can be, but I'll just be safe. No, it can't be. Otherwise, rho would have to be 0. If the origin's included, rho is 0, and then you can't get 1. So rho can't be 0, meaning the origin can't be included. Up here. Rho sine of theta equals 1. If you're at the origin, your rho is 0. 0 times anything can't be 1. So the origin is definitely not included. So y isn't strictly positive. I think this was the first time this semester we had to do like really heavy manipulation. Algebraic manipulation. Don't worry, it gets better. By better, I mean. And by better, I mean. Brush up on your algebra now. Because we start vector valued functions next. Not just constants.
Actually,
Mm-hmm.
will that be on the first test?
Mm-hmm. First test covers almost all of vectors, not motion in space. Which means after your test, we get to do physics. It's actually probably my favorite topic in this, motion in space.
I like physics, but physics is
Huh?
I said I like physics, but physics is
You like physics?
not particularly just physics, but I still like it.
That problem with proton and electric field is just way
Yeah.
too much physics for me.
Yeah.
Which one?
The one where it's a photon with an electric field,
Where?
Website. And it's
Not everyone may have gotten that. I don't know if it's in a pool that was randomized.
I got it.
I don't remember. I'll have to look at it, but yeah. And that was a simple physics problem.
I don't even know what a coulomb is.
A what?
A coulomb.
Coulomb. Coulomb is the SI unit for charge. So now you know. Wait, you haven't taken E and M?
No.
Oh, okay. That'd be why you don't know what it is. First quiz is now available. Oh, look, 2 less questions than your linear algebra quiz. That probably doesn't bode well,
So
because it's still 50
everything-
points.
Is it everything from now?
Yep.
Oh, okay.
90-minute time limit has to be done in one sitting. Once you hit take quiz, the timer does start. And it'll be due before class February 11th. That is Tuesday. Open resource. You just can't Google the answer, but everything else is fair game. Multitudes of question types can have matching, fill in the blank, multiple choice, numeric response, and file uploads. For the file upload, you will complete your work on loose leaf in either pencil or black ink. I will not accept anything else. Make sure that all of your work is legible and neat. This does mean large enough for me to be able to read it. If I can't understand it, I'm not going to grade it. You will upload that work as either an image or a PDF, recommended PDF, and it's only the work for that question. Right, so each question should probably just start a new sheet of paper. I do recommend PDF. If it takes multiple sheets of paper, you can't upload 2 images. You're only allowed 1 file upload. So the best way would just be to convert all that into a single PDF file and upload that. That's the best option. Plus, weird things sometimes happen with images where it won't let me open them. See full credit, must show all of the necessary work. I do award partial credit on the file upload questions only at my discretion. Right, so convince me you know what you're doing. I will not accept any files sent via email, message, anything. I will only look at what is actually uploaded on the quiz. 90 minutes should be more than enough time to complete it and get everything uploaded. Before starting, make sure you take care of any business, because again, the timer starts as soon as you hit take quiz and you can't pause it. And also, you might want to make sure you're in a location with a stable internet connection. If your internet drops mid-quiz, it does boot you out and won't let you back in. At which point, you only have one option, and that's to message me, and I have to reset the quiz. But that means you're starting all over. Like I said, let's hit take quiz. You'll see a timer right over here, counting down. This would be an example of a file upload. All you have to do is hit choose file and select your file. Yeah, I'm feeling risque. There we go. It's now been uploaded. Here would be an example of a multiple choice. This would not have partial credit on it. And generally speaking, any problem worth 2 points is probably not going to have partial credit, even if it is a file upload. Right, this would be a numerical response. You just have to type in your number. That was it. Okay, so out of 9 questions, 7 of them are going to be file uploads. So the vast majority of it is going to be show your work. And then once you're done, just hit submit quiz. And you're set. Good luck on the first quiz. Have a good weekend. See you Tuesday.